Hi guys, in the earlier video on k-means to determine the optimum number of clusters for a given data set, we made use of a particular method, namely elbow method. In this method, we draw a line graph resembling an arm and we try to spot the elbow area in the graph, and the corresponding x-axis value is considered to be the optimum number of clusters for any given data set. We use two terminologies during the discussion. They were one WCSS and the second inertia. So, what is WCSS? WCSS is the sum of squared distance between each and every data point and the centroid in the given cluster. So, if we have two clusters for a given data set, then we will have two WCSS. And then what is inertia? Inertia is the sum of WCSS. So if we have two clusters, then we will have two WCSS. We will add them and then we will have inertia. So if we have three clusters, there will be three WCSS, and those three WCSS will be clubbed, added together to get the respective inertia. So we did draw elbow graph using sklearn library module, and then we also discuss about having our own code. So here, so far as sklearn module is concerned, we do write two lines and it does everything for us. It spits out inertia for us. So let me run this and just see how we will get inertia. So having run that, we can say model dot underscore underscore dict underscore underscore. When we say, it shows many things. One of them is inertia. It is 14.06. And what is this all about? Look, this particular code is having one loop. It is running four times this loop. 2, 3, 4, 5. So iteratively, it is running four times. The inertia that we are seeing here belongs to the last iteration. Correct? Now, here we don't know how sklearn is calculating. Hence, we have our own custom code to explore how we can calculate WCSS and inertia. So, this is our custom code. Now, let us do one thing. Let us copy this entire thing and create a space over here, just on top of it. Enough space so that we keep this notebook neat and clean and concentrate on the task at hand. So here we go. So what we will do is, first we will just consider two clusters. So we will write 2 comma 3 means the loop runs only once. Okay. Now let us block certain areas. So maybe let me comment this area initially. Okay. From this point to this point. commented. Okay. Now let us run this piece of code, whatever is in the uncommented area. So what it will do, look, this is an empty list. This is nothing but data frame which we created. We are copying as df1. Here, this is the loop. Counter is 2. df1 lock group 0. We are creating a column by the name grp and inserting 0 in each and every row. Under that column, we are considering one centroid. This particular variable name is centroids. What we are doing? We are saying df1 sample ctr. Look, when we do, what happens? Let us see separately. df1 dot sample and ctr means what to? What it will do? From the data frame, it is going to extract two rows randomly. We got this, but we will say reset index drop. This is very important. True. See, this index number will be reset as 0 and 1. Okay. Now that we are writing sample 2, this will change. But we will see that the first row will have 0 index and the second row will have 1 index. So 0, 1. Correct? But the values will change because we are using sample. Okay. So 0, 1. Of course, the rows changed. Correct. So that is all about that particular line. Now we have seen this. We are making copy of the centroids. What is centroid? This piece, whatever we wrote, we are calling that a centroid. Let me run again and just see what is centroids. So here CTR value, I think it was 1, 2, 3, 4, 5. So let me make 2, then we will get 2 only. Okay. So if it is 2, we are getting 2 rows, right? And this is nothing but two initial centroids. For first centroid, this is x value and this is y value. For second centroid, this will be first value and this will be second value. And this is the centroid from where each and every data point will be measured to calculate distance. Okay, so that is fine. This we had seen in earlier videos as well. Then we are drawing scatter plot. Very simple. So let us run this code. So what will happen when we run execute this particular cell from here to here? It will show us the output. So this is what it is. Okay. So this all these things are getting printed. Simply ignore them. Okay. So this is what it is. Next, what we will do? Next is this portion from here to, let us consider this area. Okay. We can even remove this, keep it separately. We will bring it again. Okay. So that we don't get this output. This looks bad. Okay. Fine. Now what is happening is, in the earlier video we saw how we will settle these two centroids at their appropriate locations. Means a point comes when these two centroids will not budge from their earlier locations. So that is what is going to happen. So let us see, let us run this and just see. We are going to see another graph which will settle these two centroids. How it happens? Here we go. See, it was like this. Now it got settled. So let us not get worried about the size of centroid. Maybe the size is different. Here the size is 20, and whereas the size given over here, where was that size? Why it came so big? Look, this centroid size was 2000. Okay, that is why the difference. Let us make it 500 and just run it. The color is different. Okay, so see, initially these are two centroids and they settle over here. This we saw. This is just nothing but repeat. So this part is fine. Now what we can do? We will say go till 6. What is happening? First for 2, then for 3, then for 4, then for 5. So let us run this. See, initial 2, then these two centroids settled. Then for 3, then 3 settled like this. Then 4, 1, 2, 3, 4, 4 settled like this. Then 5, then 5 settled like this. Okay. Now, what is left? This is working very well. But again, put it back. Make it 3 only. So for two centroids, what this piece of code is going to do? So let us bring this on top. Okay. So this is the topic we are going to concentrate upon. See here, all underscore WCSS0 means if we have two clusters, we will have two WCSS. What is WCSS? It stands for within, within cluster sum of squares. So each and every data point's distance vis-a-vis this centroid would be considered. That piece we are talking about. And then it will be summed up. So likewise for this also, each and every data point's distance with respect to this centroid will be considered, accumulated, and then it will be summed up. So see what we are doing. For J in range centroids, how many centroids we have? Two. So this loop continues for two clusters. And what we are doing here, see here, WC, WCSS, we are calculating, right? How? Measure the distance for each and every data point with respect to its own cluster and then sum it up. We summed it up and that is what is called WCSS. And same thing will be done for this in the second iteration. And then what we are doing, this we are putting in all WCSS. So first iteration WCSS comes. So WCSS it is put over here. Second again this comes and it is accumulated. This time all underscore WCSS will have sum of this as well as this. And that is what is called inertia. So see, after getting out of the loop, what we are doing, my underscore inertia dot append, that in the list we are putting CTR. What is that? 2 and all underscore WCSS, nothing but inertia. So that is what it is. So if we do for 3, the same thing will happen for 3. If you do for 4, it will same thing will happen for 4 and then 5. And then what will happen? Our this particular list will contain 4 different rows. The first column will be the number of clusters and the second column will be the respective inertia. So now we have to simply go here, make it 6. So the loop is going to run 4 times and we will get 4 inertias. So let us run this. Okay. So for 2 clusters, initial clusters were this. We are ready with settled clusters. This is all about 2. Initial for 3, settled for 3. Then 4, 4 settled like this. 5, then 5 settled like this. And we are getting for 2, this is the inertia. For 3, this is the inertia. For 4, this is the inertia. For 5, this is the inertia. And then we are drawing this elbow graph. This is called elbow method. This graph is showing as like an arm. Okay. It is not looking like arm in this particular graph, but more often than not, it will take the shape of arm and we will try to spot the elbow in that arm. And we will see what is the corresponding x value, the value in x axis. And that is what is going to be our optimum number of clusters for the given data set. So let us run it again. And you know what? It was discussed several times. In K means we keep running and the output will be slightly different. It is not going to be the same all the time. Okay, so here just see. Here we will run it again and just see. Look, this is how it is coming. And let us consider this to be an bow. We will run for the last time and then we will. Okay, it should come up. Hmm. This is what it is. Okay, let us consider this. Let us not get worried about the shape of that arm. The idea is when this inertia value stops getting, going drastically lower, we should consider that particular point to be the optimum number of clusters. So that point is going to be the point which will be our final figure for considering the number of clusters. Okay, so this is 3. So now what we will do, having run this, we have to simply bring in this entire code. Okay, from where to where? What we can do is this entire code, okay, you bring some of those things will be unnecessary. We will simply remove them. So let me copy right from here to here. Having already determined the number of cluster that should be used, there is no point in running this loop. So we will write 3 and stop at that. Okay. There is no need to do calculations. All these calculations are of no use now. And just run it. Okay. Initially, this is what it was, and it settled like this. The task is done. The optimum number of clusters for this particular data set is 3, and we have drawn this graph depicting these clusters, 3 clusters with their respective centroids. Thanks for watching, and I will see you in the next video.